welcome everybody to tonight's webinar. It's going to be a little bit different than the standard webinar, where it's mostly me talking and you doing, some stuff. Today it's going to be more discussion-based. We are no longer going to be doing any Inkscape, because we are reaching the end of this semester. Next week will be our very last two classes, on Monday and Wednesday, at the same times as usual. Just a reminder, the folks that have their labs in Raleigh will have a lab in Charlotte on Saturday at 10 a.m. at the same place as we did before. And with that said, I'm going to go ahead and get started. This is a discussion-based class, and that means, it's based on the students that are here. There's not very many students here today, and in fact, poor Sam's going to get a bit of a grilling. But I would like for you watching the video after the class to consider some of the things that I talked about, and hopefully it'll inspire you to maybe look in this as a potential career path. So without further ado, I'll go ahead and get started. We're going to be talking about vertical farming, which you probably have never heard of before. To be honest, I hadn't either until I started getting prepared for this presentation. But it's actually a pretty cool concept, and we'll find out today what it is and why we actually care. And the question is it farming on a wall or something? Basically, a little bit more in depth than that, because we're looking at a lot bigger of a scale than just, a single wall. And I'm actually going to be unmuting you at some point, Sam, so you're not going to have to be talking to me through the question box. So you have a microphone and everything, right? A bad one? Alright, it doesn't have to be good. And if I can't understand you, you can always write in the question box and we could talk about it that way, if that's okay with you. So as just a little bit of background here, as of the year 2015, there's an estimated 795 million people that are not getting enough food to lead a normal and active life. And when you consider that the world population at that time is 7.2 billion, that means about 10% of the whole population of this earth is not getting the amount of food they need. And obviously that is a huge, huge problem. In this day and age, people should not be dying of hunger. And I don't say that as, my opinion. I say that as truth. Because we have enough food, which I'll go over in just a couple minutes here, but we just can't get it to people well enough. So by 2030, projections are saying that the population is going to exceed 8 billion. So that's a whole lot of people, like incomprehensible amount of people. And over half of that population today lives in an urban center or a city, or very, very near one. And by 2050, that's going to be 2/3 of our global population. So people are moving away from the rural areas and moving into these city centers where a lot of the jobs are. And the challenge becomes feeding the population somehow. And this wouldn't necessarily be an issue, feeding this population. Like I said, we do have enough food. The real issue is getting this food to the people. So there's enough food, but not the means to get it to them. Because we'll have to ship food from, say, across the country into these city centers. Some of it's going to go bad, some of it's not going to be affordable for people. And so we got to figure out ways around that. So one way that we can get more food to the population centers is by improving the yield of our current farming techniques. So this yield can offset the shrinking land, so land affected by things such as desertification and the sea levels rising. And it can also offset the decreasing manpower for agriculture. So again, these people are moving out of the farms into the cities, not as many people willing to work on these farms to produce food for people. So there's been a ton of solutions proposed for that question. The question being, is there an easy way to grow a lot of food with a small amount of land space that can then be used to feed urban centers easily? And obviously you see here vertical farming, which is essentially making farms that go up instead of sprawl, is one method of doing that. So, Sam, I'm going to go ahead and unmute you here, so I want you to think for just a second, you don't have to answer immediately. Can you think of any other possibilities on how we can do this? Other than building farms, just go straight up? And we're going to be focusing the presentation on this straight up farming, but so take a second to think, and then you're unmuted to go ahead and answer. And if you don't have anything, you can just say it.
I can't think of really much.
I couldn't either. I was just saying if maybe you had something that I had forgotten, so no worries. I'm going to go ahead and mute you just for sound's sake. But yeah, there isn't very many good ways to do that. One perhaps could be offering incentives for people to move out into these rural areas. That could be one way, but in this day and age, people are less and less willing to do that. So, vertical farming, which can be done just about anywhere, and it can especially be done outside of urban centers where there's already a whole ton of tall buildings, this could be a good option for us. So again, it's the practice of stacking farmland vertically, allowing you to have a lot more farmable land area than in traditional expansive farming. So instead of farming just on two-dimensional, sprawl of land, we can go up instead, adding that third dimension, like triples the amount of, not triples, but like cubes the amount of food we can make. An aspect of this vertical farming is called controlled environments, or climate control, which you probably know it as, where conditions that the food are grown in are carefully monitored and maintained by humans and machines. So really what we're looking for, is to maximize the yield of food that we possibly can. So everything that grows into growing a plant is going to be carefully watched and maintained to the most effective levels that they can possibly be. So again, the yield thing. And on the right here, we see a probable theory for how we could successfully build a vertical farm. So we would get energy from maybe a solar panel that can follow the sun, so we can get all the sun's energy we can, so we don't drain any of the resources in our region. Covering it in glass, if you've ever heard of a greenhouse, which I'm sure you have, makes it a little bit warmer, makes it so that the sun can completely get to the plants. And what's interesting, it looks like it also collects pollutants, so the plants are not exposed to these pollutants, which is something that I didn't know. So again, making sure we got good architecture, allowing maximum light into where the plants are. Again, it can be built in city centers because it looks just like a normal skyscraper. And it can use, irrigation. So wastewater from a sewage system could even be used to, filtered obviously, can be used to water these plants. So just a theoretical how this could be possible. Now, as awesome as this sounds, there are a whole ton of issues that vertical farms need to consider that are currently prohibiting their use around the world. So let's take a look at some of the problems that these face. So real quick, Sam, I'm going to unmute you again. Let's think for a second. What are some things that a plant needs in order to survive and grow?
Sunlight, water, nutrients, other life forms.
Sunlight, water, nutrients, and other light forms?
Yes.
Okay, for a vertical farm, yes, most definitely. Other light forms would be definitely helpful. And you're exactly right. I have a couple more that I'll be going over in terms of vertical farming issues that they're having, specifically with maintaining, temperature um, and power for, but I guess you said that in sunlight. But anyways, yeah, you got it exactly right. Those things have to be considered when building this vertical farm. So I think I'm going to keep you unmuted for the next couple minutes because I will be periodically asking you questions over the next few slides. So light's definitely one of them. So plants do transform light into nutrients via photosynthesis, which hopefully you're familiar with. Basically, photosynthesis says that light, in nature from the sun, plus carbon dioxide, which is what we humans and other um, animals exhale as waste, and then adding some water to that equals energy for the plants in terms of carbohydrates, and it also releases oxygen for us, which is obviously a very good thing. So these farms must be designed so that the plants inside can receive enough light. So what are some design considerations that we could do to have this happen? How could these buildings be designed to maximize the amount of light coming inside?
There could be might have to be some kind of artificial light involved because you can't have the sun hitting all points of a building. If it's circular, it's not going to hit uh, all 360 degrees. If it's rectangular, it's only going to hit maybe like 90 degrees at a time.
That
So you
is
might have to get artificial light.
that is a great answer. You can definitely use artificial light. That is, even today, that's used in hydroponic farming. That way we can be, growing stuff at night or growing stuff in low light areas. So that's a perfect idea, and you hit it right on the head, saying that even with a circular building, the sun is not necessarily going to be hitting all points of this building, and you definitely don't want a rectangular building for that same reason. So yeah, definitely not. You definitely did exactly what I was looking for here. Um, when I was doing my brainstorming, uh, I even had a crazy idea of having a building that could like rotate, but I don't know if that would, actually be feasible. I'm not a structural engineer, but another thing that you can take into consideration is using plants that don't need much light. So plants that are maybe native to places that don't get much light, maybe in the winter. So in the winter up north, it only might be sunny for 4 hours a day, but plants still grow in that. So that's another way that we could get around that, just by placing our plants in places where they'll get the appropriate amount of light. Um, so, good thought there. So again, artificial light. But let's think about artificial light real quick. What's an issue with artificial light? Something really
Power
big.
outages.
Power outages. Exactly. Not so much power outages, but just power in general. Power outages obviously will have an effect on it, but using lights on all the time, that wastes a lot of energy, doesn't it?
Yeah.
Yeah. And now that the population is growing so much, we might not have the same amount of resources that we used to have. We're not going to have as much oil or anything. So let's think about that. So obviously, we could use the sunlight. Duh. It's free. Plants have been using that for millions of years. Um, but is there any other way that we can harness the power of the sun other than just directly letting it beam onto the plants? What else could we do there?
Um, I know solar panels will take up sunlight.
Beautiful. Solar panels. Exactly. The sun shining quite often, ideally every day. So we can take the power that, in addition to heating the plants up, will also, give energy via solar panels. But there are still some problems with solar panels. They're kind of expensive. They're not entirely efficient, and a lot of the time they are stationary. So, what could we do with, let's think of a way to say this. What could we do with these solar panels to make them a little bit more efficient, to make them work a little bit better for us?
I don't really know right now. I can't think of anything.
And that's okay. We can always make them follow the sun. That way we get sunlight on it
Yeah,
all day. I didn't really have a
yeah.
better
Then
answer.
you have night as well, which has nothing to follow then, so you have to program it to also react at night.
I'm actually not sure if there's enough energy, like light refracting off the moon to power these at night. But solar panels could definitely be used to like harness, the energy so that we could power lights at night, for example.
Yeah.
Um, but most definitely, yeah. So the next thing we'll consider is the soil. So plants utilize nutrients from the soil to give themselves things the sun, cannot give them. This allows them to grow larger and more nutritious, which, will increase yield since people will have to grow and eat less of them. So, do you by chance have any idea of what kind of nutrients plants need?
Not specifically.
Okay. And that's alright, I don't expect you to know that. I barely knew it myself. But what can farmers use as the nutrients for plants?
Like what they put in their soil, or
I mean, soil itself could be one of them for sure.
yeah.
Um, but yeah, putting stuff in soil too could also help. What can you put in soil to make plants grow better?
Well, this is one thing, but it's not a nutrient. Worms can help.
Worms can they help like um, eat dead matter and make it into soil, and
Yeah.
yeah, that'll work. I didn't think about that actually. I was thinking a little bit more high level than that though, more like fertilizer. You
Oh
know,
yeah.
yeah, you can use either a natural fertilizer such as like cow manure, or a fertilizer specifically made for um, making plants work better. Specifically, the plants or the nutrients that plants need are nitrogen, which is number one. I'll talk about nitrogen in just a second here. Phosphorus, potassium, sulfur, calcium, and magnesium. We need some of that stuff too, but we don't need nitrogen as badly as these plants do. And I wanted to go on a little bit of an aside here to talk about nitrogen, because before the 20th century, we didn't really have a good way to have these big scale farms because we didn't have a way to convert nitrogen from the atmosphere into nitrogen in soil so that plants could actually use it. So this guy named Haber, he realized that via a series of chemical reactions, he can take he can take nitrogen from the atmosphere. The atmosphere is 79% nitrogen gas, and add hydrogen gas plus some energy to make ammonia, which is the same thing as the cleaning product. But as it turns out, ammonia is a really good fertilizer, and it led to more productive yields. And this guy managed to make the process so streamlined that we could yield more and more and more and more food. So this guy is the reason that we're able to make so much food nowadays. Um, so I didn't really have anything on this slide beyond that. So I guess I already talked about fertilizer. So there is natural and synthetic fertilizer, and even though there is fertilizer, it's not very easy to fertilize every single square inch of soil in a vertical farm, and it can definitely pollute the environment if distributed incorrectly. I don't know if you've ever heard of something called an algal bloom, which is when a whole bunch of algae grows really, really quick. Um, Algae is a plant, It's just in the water. And if fertilizer gets into the water, this algae is like, oh yeah, I'm going to get some of this fertilizer in me, and it blooms and it kills all the fish, and it's really bad for the environment. So fertilizer, still not, the best thing in the world, even though it helped a whole lot. So natural fertilizers will involve byproducts from animals and plants. They are organic components that usually are not otherwise desired. The byproducts could be like animal waste or decaying plant matter, and that goes in with your worms, and the remnants of, dead stuff. And then we go back into the synthetic, um, which has all the same nutrients, but manufactured by us. Once again, more efficient uh, and it hurts the environment. Sorry, this slide was not included when I first went through these slides, so that's pretty cool. So the next thing plants need, water. It is the lifeblood of plants. Plants use this water to move nutrients around their bodies, and they will die of thirst without it. But water can be expensive or not easily obtainable or in a very short supply. So, what are a couple ways that architects can increase the amount of water that plants get while using less of the city's water? So, when I say the city's water, I mean water meant for people. What can we
Yeah,
do?
I was thinking like already used water, like
Mm.
sewage water.
Yep, already used water is a very good one. Um, we could definitely use water that has been treated in a sewage plant, maybe. Take out all the bad stuff and keep the good stuff. That'll definitely work. Now, what about natural sources of water in the environment? What could we do there? How can we harvest water or relocate water easily?
Um, well, you can build dams and things like that.
Yeah, you can dam a river and make an irrigation canal so that water from
Yeah,
miles and miles away can be taken into our building for sure. What about rainwater?
rain barrels. Yeah, they work.
Yep, they definitely work. Unfortunately, in some places there isn't, very much rain or water in general, right? So that
Yeah,
becomes a little bit more challenging there. And that goes back to growing plants that are suitable for your region. So someone in maybe Saudi Arabia wouldn't be planting water chestnuts, maybe.
yeah,
But exactly, good couple points there. And again, rainwater is great. You don't even necessarily need rain barrels if you design your building correctly. You can just have water directly fall into your plants, or you can have the building collect water, maybe. Um, and that way plants will not have to rely on the city's water grid. And what are some challenges or hurdles be with this method? I already kind of went over one with the having to design the building, or what if there's not enough water? Do you have any other
yeah.
things that you want to bring to the table there?
Well, I feel as though something like more rain barrels in more locations would collect more overall than a design of building in one place, and that can enlarge that by a lot.
Okay, yeah, that could definitely work. Though instead of having normal like plant farms, we can always have water farms. The only thing I can
Yeah,
see there is having trouble transporting the water back to where our farms are. But at the same time, we can do pipelines. We do that already. Um, this is one I hadn't really thought about until just now. So good answer, good insight there. Cool. Another way that we could do this is via water desalination. So taking salt water and converting it into fresh water. Especially in California, where there's like a notorious water crisis right now. Um, these plants are getting built, It'll take ocean water, remove the salt, and this fresh water can be processed into usable either drinking water or plant growing water. Now, only 4% of the water on Earth is fresh water, and like a tiny, tiny fraction of that is potable fresh water. Um, but what about maybe brine, which is like incredibly, incredibly salty seawater that is left over from this process? So when we desalinate water, we get nice, clean, fresh water, but a whole lot of super salty water. Can you think of anything else that desalination of water could cause, maybe environmental effects?
Well, when they have that salt water left over, well, the really salty water, I think you said brine.
Hmm.
Yeah, that can get places and just make a certain area very salty, which too much salt for a certain ecosystem will ruin it.
You got it. It's just like in the winter when they salt the roads, and it's some in some places where there's too much salt, plants won't grow anymore. Not at least for a little bit. The phrase "salting the earth" is a thing for a reason, but also making the oceans a little bit more salty, and that'll affect all the life inside the ocean. So too much salt is a bad thing, um, even though it tastes delicious on French fries. Um, but yeah, overall, desalination does have a bad impact on the earth, even though it's in the short term doing us good. So the next thing we're going to talk about is temperature. Like all other organisms, plants can only live within a certain range of temperatures. That can vary from plant to plant, but every plant does have a preferred temperature range. So we got to actually regulate the temperatures in these vertical farms to make sure it's not too hot or too cold. So what could a building designer do to save energy while taking into account the temperature required for these plants?
Well, first they could put all the plants that require the same temperature on the same
Yes.
area. So that way they don't have to kill some and keep others. And then to keep temperatures consistent, I'm not exactly sure what exactly it is, but thermoses seem to be doing a great job.
Okay, so climate control basically using heating and air conditioning to ensure that the temperature is looking good, right?
Yeah,
Yeah. Um, Perfect. Another thing that you could do here is heat rises. Put plants that require higher temperatures on the top floor and lower
hmm,
temperatures on the bottom. Among other
yeah.
things, keep some plants that don't need as much heat, but more than other plants in the back where they don't get quite as much sun. It just depends on the plant, really. Um, but there are a couple sneaky ways that you can swing that. And you're right in saying that climate control is a wonderful thing, um, especially air conditioning. We live in the South. We desperately need air conditioning nowadays. Um, and it does provide a whole lot of control over the environment, but there's still some challenges here. So the side effects of climate control. Can you think of any?
Um, not off the top of my head.
Not good for the environment, for one. I mean, you should see my energy bill after a month of hot summer days and using my air conditioner. I use a whole lot more energy, and again, that's not good for the environment. We don't have an infinite supply of this energy, um, so I can't really think of any other things other than that. But there are some side effects to using climate control. So we could also sneakily use windows and ventilation systems to regulate the temperature of a building. Even, today we are seeing buildings that are constructed with reflective windows that will allow the sunlight and therefore some heat energy to bounce off of the building, and we can keep the cool inside. Um, any other ideas of what we can do to regulate temperatures without air conditioning or heating? Insulation is sort of something I
Not
missed.
really off the top of my head.
Yeah, I can't really think of one either. I think we've already covered a lot of that. So, alright. Another consideration we gotta do. It's the space. Because plants do need some space to grow. They can only grow so big if they only have so much space. So how can we increase the space for growing plants? I mean, the fundamental thing of this class is to increase the space to make plants by vertical farming. But I mean specifically in the design of a building.
Uh, I mean, you could take results of like a range of how big the adult plant gets to be, and once you have the range of how big the adult plant will be, you can give that much space between the seeds.
Okay, I like that. And to go one step further than that, you can design the building in mind for the plant. You can put
Yeah.
the plants that need more space on maybe a bottom floor where they can get more space. Did I have any other notes on that? So obviously the vertical tower does add the third dimension, um, and that's all I had on my notes about that really. But exactly, you can design for the plant. Let's see here. In addition to making sure the plant gets what it needs, the building needs to be structurally sound. So there are some challenges just in terms of the stuff we use to build buildings and the stuff we use to build plants. There's a little bit of incompatibility there. So, could you think of something that might not be good for a building that plants require?
Ugh. Certain metals might affect the plant's growth.
Ooh. Okay, see, that's a really good idea. Certain metals can affect plant growth. Yeah, definitely. We have to consider the metal that the plant is directly touching because some metals can leach into the soil. We really don't want to be, contaminating anybody. But really good point there. Wow. What I was thinking personally was just water isn't necessarily good for a lot of metals. It can weaken the structural integrity of the building itself. So,
Yeah.
just ultimately, stuff plants need and stuff that buildings, structures need to stay stable, um, aren't necessarily gonna work nicely together all the time. So, material, big deal there. Also, natural disasters. So, no matter where you live, something's gonna happen eventually. Maybe it's a weather hazard or an earthquake or something like that. Um, Stuff that's just not good for a building, obviously. So, what can we do to combat these natural disasters? That's a really dumb question.
Um, Build the structure as you would for any other building that's built to survive natural disasters, and if that requires a lot of room on the ground floors, then keep the plants on higher floors.
Exactly. Build the building for the environment around it. I just thought this question itself was kind of dumb. We cannot combat natural disasters usually. We just have to protect what we've got and pray for survival, basically. We unless we want to like go out and punch a tornado. Yeah, not gonna happen. I mean, it could, but we also have to consider the aesthetics of a building when we're designing it. Um, if a building is ugly, just in the very early planning periods, people aren't gonna want to have that building, in their city. Like this horrible building you see here. I don't even know how that got approved. Um, but you're gonna have a harder time to build it ultimately.
Aren't any windows?
I'm trying to. I don't know if there are windows. It's just sort of the same color as the facade, but it's a terrible design regardless.
Yeah,
I think it might just be complete concrete.
which is not good at all.
No, that's horrible. It might be good for like a nuclear reactor, but not for a telecommunications building. But definitely brainstorming these building ideas to make them aesthetically pleasing. It does make a difference. Alright, so power. Farming does require power, as I've been sort of sprinkling throughout, and vertical farming is going to require a ton of power. And then more, so that we can make it as efficient as possible. So, what are some ways that we can generate power? We've already gone over solar
Um,
panels.
it's power you can create using water and the way water flows and friction.
Hydroelectric, perfect. I love
Yeah.
it. Hydroelectric or wind or geothermal, great sources of power. Because, like I've been saying, we're not going to have these fossil fuels forever. We got to start embracing these other methods. I mean, even nuclear power, not a bad method. Um, and the reduction of power. Um, how could we reduce power in these buildings?
I mean, if you are going to try to use artificial light throughout the building, there's not much way to reduce power.
Using artificial
But
light. Yeah, I'll agree with you there.
I can't really think of anything. You might have, but I can't think of anything.
You could always try and plant plants that are native to the environment. I think I said that a little bit earlier, but so that they don't have to, or so they, sorry, that they already have the amount of sunlight they need, for example. Um, but other than that, just making more efficient items like lights and stuff, that could definitely work too. All right. Um, right now, I don't know if there's any actual working vertical farms, but they can take their power from the city's electrical grid if they really want to. If there is infrastructure already in place, then why bother going through all the rigmarole to solve this power situation? So it might actually be advantageous to, you know, just plug it into the grid and say bye. Okay, whatever, we're good with this. Um, so it's in terms of advantages, it's super easy. It's a lot easier than trying to find another way to generate power. But as we've been talking about the disadvantages, just in terms of alternative power is a little bit expensive, having to
Mhm.
fund and plug in alternative power, and is there anything else I'm missing here?
Power outages also still
Yep,
affect.
there we go. Power outages, not necessarily good for the plants. um, so it is a bit of a trade-off here. Um, tit for tat. You just really got to weigh the pros and cons of the current location that you're building this in to, be successful. So, what else have I got here? Where's power? All right. So, if having enough power is a concern, structure could always generate its own power. I think I've already talked about this. I think he's been adding a lot of slides as I've been talking, so I don't remember seeing like half of these. um, but yeah, like I said, solar power, other stuff like that. Stuff like that, very vague, right? So these designers have to consider all this stuff, and that's like a lot. That was like 40 minutes of stuff that we talked about here. Um, so what I want you to do, Sam, is to get an idea of what a vertical farm could possibly look like. It's not like you have to, do any crazy schematics or anything, but just given the stuff that I've talked about and some of the concept images, I just want you to have an internal thought of how this could work out. So let me know if you think you have a vague idea here. And again, you don't have to talk about it or anything, it's just an idea.
Yeah, I have an idea.
Okay. It's Probably took you a couple seconds, though. It definitely did, because there's a lot of stuff that you got to keep track of here.
Yeah.
Yeah. But luckily, engineering is about incremental improvements, so just step by step, talking to people, adding their ideas, realizing some ideas don't work, realizing some work great, um, basically making these improvements, working with other people around the world. So these huge scale problems, like these vertical farms to combat world hunger, they require cooperation, as does everything in engineering, as I've been trying to emphasize over the semester. Um, you might not be able to do one completely on your own, but any contribution is going to help. So while we're looking at the big scale, maybe we should look a little bit at the smaller scale here. If we can improve one part of this, so maybe making a more efficient solar panel, finding a new, more effective way of growing plants, um, maybe that could be something that you can go look for in the future, and maybe make one of these things real at some point, you know? So maybe if you like building design, you can look at the latest materials that are being created to incorporate them into the new buildings so that these structures can be
Hmm.
taller, stronger, more disease resistant. Not disease resistant, I meant disaster resistant. But I guess, disease resistant could help with the plants. Um, or maybe you would want to get into bioengineering, make these plants grow bigger, less nutrients, and less sunlight, making water efficient plants that can be grown into maybe a farm vertically. So it looks like there's still being stuff added, but I don't want to stress them out too much. Um, so, Sam, do you have any questions on what we've gone over today? Really, anything at all?
I don't have any questions, but when you mentioned diseases, you actually gave me an idea.
Yeah, what's that?
Uh, there's a certain kind of tree called a hemlock, and there's a disease that kills it at a very, like, before it can really become a big tree.
Hmm.
And I was thinking maybe doing so we could keep that type of tree alive.
Yeah, definitely. Maybe bioengineering more in the microorganism side.
Yeah,
So figure out a way to either, make the trees themselves more resistant or make the disease less intense.
yeah,
So definitely another side that you can be looking into here. There's so many different types of engineering that go into this that if you find an interest in anything, there's space for you, and you can definitely make the world a better place.
yeah,
So this has been kind of fun. I hope that it didn't
yeah.
stress you out too bad.
No,
Oh, good deal. So, want to take a look at this last slide that's being created?
sure.
See what's going on? Alright, finish it up after that. So, yep, one example of problems that people will be facing. If we work together, we can bring ourselves to solve the problems of the many, or maybe all, of these major problems. And again, that's what engineering is about, finding solutions to problems, making the world better. So, perfect summation of that. So,
All right.
any other thoughts or anything like that?
I don't think so.
Alright, cool, cool. Well, in that case, I'm going to go ahead and end the webinar today. Thank you for an interesting discussion, Sam. It's been great.
Yeah.
And I will talk
Thank
to you
you.
next Monday. You're welcome.
All right.
Bye.
Bye.